The last sections here in Chapter 3 are all about parallel and perpendicular lines and their slopes. So the whole unit we've been talking about parallel lines and what we get from them. Now we're going to talk about how we can show lines are parallel and perpendicular and write their equations. So quick review. Slope is defined as the change in the y-axis coordinates divided by or over the change in the x-coordinates. A lot of times people remember that as rise over run. And then the formula we use for that would be the y2 minus y1 over x2 minus x1, because that's how you would find the change in y is finding the difference, the change in x is finding the difference in the x's. We usually use the variable m to represent slope. So if I get the question, find the slope of the line passing through the points 3, 5 and negative 2, 1, well 3 is my x1, 5 is my y1, first x coordinate, first y coordinate. Negative 2 would be my x2, 1 would be my y2. So to use the formula, it would be y2 of 1 minus y1 of 5 over x2 of negative 2 minus x1 of 3, and I'm going to get negative 4 over negative 5, which does reduce and simplify down to a positive 4 over 5. Now I always get the question, does it matter what I use for x1 and x2? It doesn't. If I had wanted to call this x2 and y2 and this x1 and y1, it doesn't matter. What matters is you leave the 2's together, x2, y2, x1, y1. That's the important part. So if I had done this backwards and I'd said y2 is 5 minus 1 over the x2 of 3 minus the x1 of negative 2, that would have given me a positive 4 over a positive 5, and I get the same thing. The only difference is you might have to deal with this double negative and simplify. But it doesn't matter which one you call x2 and which one you call x1. You could find the slope then from a given line. A lot of times you can just count. You could say this is rising 1, 2, 3, 4, 5, 6 units, and it is running to the right 1, 2, 3. Well, I went up, which is a positive 6, and I went to the right in the positive direction, so that's a positive 3. So my slope, which would be rise over run, would equal a positive 6 over a positive 3, which does reduce down to a 2 over 1, or we just say the slope is 2. What that means is I didn't have to start at these 2 points, but to go to the next point it would have been up 1, 2, right 1, up 1, 2, right 1, up 1, 2, right 1, up 1, 2, right 1. So I'm constantly getting to the next point on the line by using the slope of up 2, right 1, or a slope of 2. If I didn't want to do it that way, I could have used the formula as well. This is the point 0, 0. This is the point 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6. So this is the point 3, 6. Well, if I use the slope formula, y2 minus y1 over x2 minus x1, my first y is 6 minus my other y of 0 over my first x of 3 minus my second x of 0. Notice I'm going to get the 6 over 3, which does reduce down to 2. So you can either count and use the rise over run method, or you can just look at the points and calculate the slope using the formula. Slope-intercept form of a line is y equals mx plus b, where m, we already said, represents your slope. B is your y-intercept, or the point where it crosses the y-axis. So the y-intercept is the point where the line crosses your y-axis. If we use slope-intercept form, when I look at number 1 and where it says find the slope of the following lines, if I were to write y equals mx plus b underneath, 3 matches up to the m, 2 matches up to the b. So my slope is 3. On number 2, again, y equals mx plus b, negative 2/5 lines up with the m. My slope is negative 2/5. So people start to say things like, oh, the slope is just whatever's in front of the x. And you're right if you're in slope-intercept form. Number 3 is not in slope-intercept form. It's got the x's and the y's on the same side. So we got to change it around a little bit. I would subtract the 3x from both sides. which is going to leave me negative 2y equals a negative 3x minus 6. Notice I leave the x in front of the number 6 because I want the x then the b. So m then b. Then I'm going to divide by negative 2. Notice I'm dividing every number by negative 2, not just the 3, not just the 2. This leaves me y by itself. A negative 3 over a negative 2 is a positive 3 halves x. Negative 6 divided by negative 2 is a positive 3. So now if I were to write y equals mx plus b, 3 halves lines up with the m, so my slope is 3 halves. My y-intercept would have been 3. On number 4, here's that unique case of a horizontal line. Whenever you have y equals, you're looking at a horizontal line. Because if I was to make an xy chart, y, according to the equation, is always negative 5. So no matter what, this equation says y is negative 5. So if x is 1, y is negative 5. If x is 3, y is negative 5. If x is negative 2, so on and so forth. Any number I pick for x, y is negative 5. Well, if you were to graph that, that would be 1, negative 5, 3, negative 5, negative 2, negative 5, 4, negative 5, and we end up getting this horizontal line that is represented by y equals negative 5. Well, the slope of that, you could do the rise over run method. If I start at this point, I'm rising 0, but I am running 2. Well, my slope then would equal a rise of 0 over a run of 2. 0 divided by 2 is 0. So the slope of any horizontal line is 0. Number 5 is the exact opposite of that. If x has to equal 3, again, if I made a quick xy chart, x has to be 3. I get no choice for x. It's 3. But if x is 3, y could be anything. It could be 1, it could be 2, it could be negative 3, it could be 4. If I graph that, well, I would be at 1, 2, 3, 1, 3, 2, 3, negative 3, 3, 4, and all my points line up in this perfect vertical instead of horizontal line. So if you ever see x equals, that is your vertical line. Again, let's use the rise over run method of finding the slope here. If I start at this point, I am rising 1 unit, but I am running in the x direction 0. I'm not going to the right or to the left at all. So if I use my slope here, I would say the slope is the rise over the run, 1 over 0. You can't divide by 0, so I end up getting this idea of undefined. So if you are ever asked for the slope of a vertical line, we say it's undefined, whereas the horizontal line has the slope of 0 because you're rising 0 and running whatever to get to the next point. So remember that. Horizontal, slope 0. Vertical line, slope is undefined. On to the parallel and perpendicular part. Again, I feel like this is a review, so I'm going to go through this kind of fast. Parallel lines, we know that the slopes are equal. Perpendicular lines, the slopes are negative reciprocals of each other. If you don't remember what a negative reciprocal is, here's an example. If I give you the number 3 halves, the reciprocal would be 2/3. So negative reciprocal of 3 halves would be a negative 2/3. If I had the number 2, and it was a negative 2, let's say, the negative reciprocal would be 1/2, because it would be the opposite, positive, and the reciprocal, which would be 1/2. So are the following lines parallel, perpendicular, or neither? We want to look at slopes. Well, number 1, these are in y equals mx plus b, or slope-intercept form. This one has a slope of 3. This line also has a slope of 3. These are parallel because the slopes are equal. Number 2, again, we're in slope-intercept form. This has a slope of 1/2, y equals mx plus b. This has a slope of 2. Well, those are reciprocals, but perpendicular lines have slopes that are negative reciprocals. So in number 2, these are neither parallel or perpendicular because my slopes aren't equal and they're not negative reciprocals. Number 3, you got to be careful. If I were to graph number 3, I think that's the best way to look at this. Y equals 2 is your horizontal line going through the y-axis at 2. X equals 9 is a vertical line going through the x-axis at 9. Well, a vertical line and a horizontal line are going to be perpendicular to each other. So I know these are perpendicular. But perpendicular lines are supposed to have slopes that are negative reciprocals. Well, we remember that the slope of a horizontal line is 0. So the slope of this horizontal line is 0, and the slope of this vertical line is undefined. Is 0 the negative reciprocal of undefined? The answer is yes. You could write 0 as 0 over negative 1. Well, if 0 over negative 1 is 0, the negative reciprocal of that would be a negative 1 over 0. Positive instead of negative. So the negative reciprocal would be positive 1 over 0, which is undefined. So it does fit this idea of perpendicular lines have slopes that are negative reciprocals. I would rather think of that as a vertical and a horizontal are going to cross and be perpendicular. What about number 4? The line through negative 2, 6, and 8, 1, and the line through 4, 3, and 6, 2. Well, I need to know the slope of both lines before I can decide if they're parallel or perpendicular. So I'm going to use my formula here. The slope of the first line would be the y, 6, minus the second y, 1, over the x, negative 2, minus the other x of 8. 6 minus 1 is 5, negative 2 minus 8 is negative 10, which gives me a slope of negative 2. The slope of the other line, I need to know that as well. So that would be the y of 3 minus the other y of 2 over the x of 4 minus the x of 6. 3 minus 2 is 1. 4 minus 6 is negative 2. Which, again, negative 2 and negative 1/2 are reciprocals. However, they are not negative reciprocals of each other, so this is neither parallel or perpendicular. They're not the same, and they're not negative reciprocals. Well, I could ask you to find the equation of the lines that I'm talking about. So number 1, let's write this in slope-intercept form. We're going to write everything in slope-intercept form, or y equals mx plus b. In number 1, I give you the slope, and it goes through the point negative 2, 5. So if I were to write this, y equals the slope of 2 times x plus the y-intercept of b. What I don't know is where it crosses the y-axis. But what I'm given is an x-coordinate and a y-coordinate. I can take those values and substitute them into the slope-intercept form and calculate what the y-intercept is. If y is 5, when x is negative 2, then this should come out to give me the y-intercept of b. So 2 times negative 2 is negative 4, plus b is 5. I'm going to add the 4 to both sides, and I'm going to get 9 is equal to b. If I'm finding the equation, my answer would not be 9, but y equals the slope times x plus the y-intercept. Number 2 asks for a vertical line through 0, 9. Vertical and horizontal lines I like to sketch. If it's a vertical line through 0, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, I have a vertical line going down through the y-axis. Well, that's hitting the x-axis at 0. So the equation of that line is x equals 0. the equation of any vertical line is going to be x equals whatever that x coordinate is. That's the equation of my vertical line. Number 3, I'm given 2 points instead of a slope. All that means is I need to figure out what the slope is and do this like example number 1. The slope would be 7 minus negative 3 over negative 2 minus 3, which gives me 10 over a negative 5, which is a slope of negative 2. So if I write that in slope-intercept form, y equals mx plus b, in goes my slope of negative 2, and all I have left to find is the y-intercept. Here's an x, here's a y, here's an x, here's a y. It doesn't matter what I choose, but I want to use the x and y that go together when I substitute in. So I'm going to take negative 2 and drop it in for x, and I'm going to use 7 and substitute it in for y. So 7 should equal negative 2 times negative 2 when I have that y-intercept. So I solve this for b. Negative 2 times negative 2 is 4, plus b should equal that 7, so 3 should equal my y-intercept. So my equation would be y equals my slope of negative 2 times x, and then positive 3 was my y-intercept. Example number 4, same idea as number 1, except this time I threw in the part about parallel. Parallel means same slope. So if I want to be parallel to a line y equals 2x plus 1, the slope of this line is 2, which means the slope of my line is going to be the same. So I start just like I did the other examples, y equals mx plus b, but I know my slope is going to be 2. So the whole task is to find the y-intercept. Well, I'm given a point that it passes through, so I can use this x and this y in my equation. So 2 should equal 2 times 5 plus b. Calculate my y-intercept. So 10 plus b should equal 2. That means negative 8 must equal my y-intercept. So the equation that passes through that point and is parallel to this line would be y equals 2x minus 8. Last example, if I want something that is perpendicular to, then I know that I need negative reciprocals as my slopes. So my first task is to find the slope of the line that I want to be perpendicular to. Well, my slope is not going to be 2. I have to put this in slope-intercept form. So I would say 3y is equal to negative 2x plus 1. Divide everything by 3, and I get negative 2/3 x plus 1/3. So the slope of the line that I'm perpendicular to is negative 2/3, which means my slope needs to be the negative reciprocal of that. So the reciprocal would be 3/2, and the negative of a negative would be positive. So my slope is going to be 3/2. So y equals mx plus b, which means y equals my slope of 3/2 times x plus b. Again, the reason you are given a point that the line passes through is so you have an x value and a y value that you can use to find the y-intercept. So I substitute in 3 for y, negative 1 goes in for x, and I calculate the y-intercept. Negative 1 times 3/2 is negative 3/2 plus b equals 3. Don't reach for your calculator, make a common denominator. I'm going to have 3 plus 3/2 equals my y-intercept when I move that over. 3 over 1 has a common denominator of 2, so I'm taking 6 over 2 plus 3 over 2, which is 9 over 2 for my y-intercept. Leave your y-intercepts as improper fractions. I don't want mixed numbers, I don't want decimals. My equation then here is going to be y equals a slope of 3/2 times x plus my y-intercept of 9/2.